So analysis of variance. So this method is used when we want to consider more than two population. Okay. So normally in your testing hypothesis in chapter 3, we only consider for one population and two population where we conduct Z test and also T test. And then if we want to test for difference between proportions, so again, we will use Z test and then pool estimate. And then the other one, you want to check for testing for a single population variance. And then we have testing for ratio of two population variance where we use the F test. Okay, that is basically in chapter 3, testing hypothesis. Okay, when we want to consider more than two population, okay, more than two population, we will use analysis of variance, or the simplified form, we call this one as ANOVA. So ANOVA or analysis of variance. Okay, so analysis of variance. So let's say, okay, kita consider this one in this example. So the same thing dalam example dalam buku tu, cuma saya inilah bentuk soalan yang lain lah dia punya example dia. Okay. So let's say we have a manufacturer of paper used for making gift bag is interested in improving the tensile strength of the product. Okay. So product engineer thinks that the tensile strength is a function of the hardwood concentration. Okay. So in this case, the hardwood concentration is called as factor. Okay, factor yang kita nak kaji. Okay, the team investigate for hardwood concentration. Okay, for hardwood concentration. So we have 5%, 10%, 15%, and 20%. So this one is called as level. Okay, kita ada 4 level. 4 level in this case is your hardwood concentration is a factor. Okay, we have 4 hardwood concentration, 5, 10, 15, 20%. So that is level. Okay, and then they decide to test 6 specimens for each concentration. So that's mean under each concentration, 5%, 10%, we take for 6 observation. Okay, so 6 observation. So this is your hardwood concentration. Okay, ini kamu punya level tadi. Okay, this is your level. Okay, kita punya factor dia. Okay, factor dia yang kita nak kaji adalah one factor je, which is hardwood concentration under 4 level. Okay, then we take an observation. So this is your observation, which is you have 6 observation in this case. Okay, so when we have a single factor, okay, when we have a single factor, okay, when we have a single factor, so this one is called as one-way ANOVA. Okay, ataupun one-way analysis of variance. Okay, one-way, satu hala. Analysis of variance, satu hala. So single factor, you have one-way ANOVA. Okay, so you can have 2 factors, which is two-way ANOVA, and also you can have multi-factors lah. Okay, kita akan ada multi-ANOVA. Okay, but in your syllabus, we only consider a single factor. So in this case, we only study about one-way ANOVA. ANOVA stands for analysis of variance. Okay, analysis of variance. Okay, let's say, okay, in the case where the number of level is greater than 2. Okay, ini kita denote K kita sekarang ni, kita pakai for representing number of level. Okay, number of level. So your K is greater than 2. So it can be either 3 or 4 and so on lah. Yeah? So it assume that there are K sample from K population. So one very common procedure dealing with comparison of multiple population mean that is comparing more than 2 population means, so we use ANOVA, which is analysis of variance. So since we are dealing with only one factor, so this one is called as one-way ANOVA. Okay. So it's reflect back on chapter 3 on testing hypothesis. We want to test whether the population mean is the same or not. Okay. So in this case, we set your null hypothesis as, let's say, mu. Mu is your population mean. So now mu1 equals to mu2 equals to some value of mu k. Okay, mu k tu depends lah berapa number of level kamu ada. Kalau let's say yang example tadi kita ada, now kita you have your mu1, mu2, mu3 equals to mu4. So this one. Okay, your alternative, you just write down mu I is unequals to mu j for at least one of ij. Okay, that is at least one of the mean is not equal. Maksudnya dalam now kamu tu semua all population means are equal. Your alternative at least one of the population mean is not equal. Okay, kalau let's say if you want to write in terms of sentence, so that's mean your null, okay, your null, all population means all your population means are equal. Okay, your alternative, at least one of the population mean is not equal. Okay. Sekurang-kurangnya satu. Okay, itu kalau let's say if you want to write in terms of sentence. So now if you want to write in terms of symbol, so we have now mu1, mu2 equals to mu k. Alternative, mu I is unequals to mu j for at least one of ij. Okay, so itu cara kita nak tulis dia punya null hypothesis. Okay. So in one way ANOVA, okay, one way ANOVA, the assumption that we need. Okay, apa dia punya assumption dia? So each sample is drawn from normal population, okay, taburan normal, with the same variance. Okay, ataupun with common variance. Okay, you assume that populations are independently and normally distributed with the same variance. Okay, each observation can be written in this format. Kita ada model equation. Okay, sebab one way ANOVA ni kita panggil sebagai model analysis of variance. So dia mesti ada model equation. So model equation can be written as Yij equals to mu I plus Eij. Ataupun ini bentuk dia bukannya epsilon. Okay, epsilon Ij subscript. Okay, Yij is your observation. Yij kamu ni kamu punya observation tadi. Okay, observation. Okay, mu I kamu punya mean for each level tadi. Okay, mu I maksudnya mean for level 1, mean for level 2, mean for level 3, mean for level 4. Eij is your random error. Okay, your random error, we assume that it is normally distributed with mean 0, variance sigma square. Okay, so ini dia punya first equation Yij equals to mu I plus Eij. Okay, your mu I ni, okay, mu I ni kamu punya mean you can write down, kita boleh split kan, mu I is the same thing if you write mu plus alpha I. Okay, ini saya tulis mu I equals to mu plus alpha I. So Yij equals to mu plus alpha I plus Eij. Okay, I kamu ni, I equals to 1, 2 up to k. Number of level tadi. Kalau macam tadi kita ada hardwood concentration, kita ada 4 level. So that's mean your k is equals to 4. Okay, inilah contoh k equals to 4. Okay, j 1, 2 up to n. Okay, n subscript I. Number of your observation for each treatment. Okay, kalau kita tengok tadi. Okay, so maksudnya kat sini. Okay, ni k kamu. Okay, k equals to 1. K equals to 2, K equals to 3, K equals to 4. Okay, this is your level So that's mean your K is equal to 4. Okay, your observation. Kita ada semua sama, 6 observation. So in this case, your Ni is equals to 6. Maksudnya, N1 is equals to 6, N2 is equals to 6, sampailah kita ada N4 is equals to 6. 6 observation. Okay, in terms of symbol ini symbol K is number of level. Your Ni is number of observation for each level. Okay. So number of level, okay, level So it's the same thing if we call this one as treatment. Okay, number of level kalau kamu nak sebut sebagai number of treatment pun sama. Okay, number of level or number of treatment. So that means you can have I equals 1, 2 up to K. Number of treatment is K. Okay, let's say number of treatment is 4 ataupun number of level is 4. So it's the same thing to test about the treatment mean ataupun kita nak test for treatment effect. Okay, satu lagi kita ada term effect Okay, yang tadi kita ada mu I. Okay, mu I is the mean. Okay, the mean for each level. Okay, bila kita dah split mu plus alpha I, your mu is the overall mean. Overall value, overall mean. Alpha I ni adalah the I treatment effect. Kita ambil effect dia, kesan dia. So alpha I is the I treatment effect. Okay. Dalam kamu punya hypothesis, you can write down either you want to test about the treatment mean or treatment effect. Katakan tadi kita tulis untuk untuk apa? Ya. Okay, this one lah. Okay. So we are interested in testing the equality of treatment mean. Kalau nak test for mean, so kamu tulis macam ni. So mu I equals to mu J, alternative mu I is unequals to mu J for at least one IJ, where your I is unequals to J. Okay, I tak boleh sama dengan J lah. Kalau I sama dengan J, it's the same value. Okay, mu I unequal to mu J for at least one of IJ, where I is unequals to J. So this one is equivalent for testing the hypothesis of treatment effect. So kalau nak test for treatment effect, null kamu alpha 1, alpha 2 up to alpha K is equals to 0. Your alternative, alpha I is unequals to 0 for at least one I. Okay, so that is the fix cara nak tulis null hypothesis and alternative hypothesis for ANOVA is fixed like this. Okay, dia tak ada yang macam testing hypothesis when you use t-test or z-test. When you have one-sided or two-sided test, tak ada. Kita fix null kita mu I sama dengan mu J, alternative mu I is unequals to mu J. Kalau nak test for treatment, alpha 1, alpha 2, alpha K is equals to 0. Alternative dia, alpha I is unequals to 0 for at least one I lah. Okay, di mana I kamu 1, 2 up to K kamu tadi. Okay. Okay, that is the way how you want to write for treatment effect. Okay, kesan treatment mean ataupun treatment effect. Okay, kita go back. Okay, ini kita punya assumption Okay, sekejap saya tulis balik. Okay, so kita nak look at dia punya assumption of one-way ANOVA. So the first assumption, each sample is drawn from a normal population with the same variance. Okay, yang second punya assumption, okay, your EIJ is normally distributed with mean 0 variance sigma square with restriction summation alpha I is equals to 0. Okay, ini dia punya assumption So first, kita ada tadi, okay. So you can write down. So each sample, so is drawn from a normal population. Ataupun kita, okay, from a normal population with the same variance. Okay, the same variance ataupun constant variance, benda yang sama maksud dia sama je. Kalau kamu nak tulis constant variance, maksudnya setiap population tu variance dia sama, which is sigma square. Okay, so that one. So it's drawn from a normal population with the same variance. So yang kedua, your EIJ, okay, your EIJ, okay, EIJ is normally distributed mean 0 variance sigma square. Okay, dengan dia punya restriction dia summation alpha I must equals to 0. Okay, so itu assumption of assumption of ANOVA model. So each sample is drawn from a normal population with the same variance or constant variance sigma square. Your random error, okay, your random error here, okay, random error which is EIJ is normally distributed with mean 0, your variance is sigma square, with the restriction summation alpha I must equals to 0. Okay, alpha I ni kamu punya treatment effect tadi. Okay, so this is the assumption of ANOVA model. Okay, dalam nota tu dah ada cuma dia tak tulis one by one lah dia just simplify kan. Okay, so that is your assumption for ANOVA model. Okay, you can test about the treatment mean ataupun you can test about the treatment effect. So when we call this one as treatment mean, mu I kamu tu, mu1 equals to mu2, mu3, mu4. Treatment effect, alpha kamu. Okay, alpha is your treatment effect. Okay, treatment ataupun level sama je lah, number of level, number of treatment and so on. Okay. Okay, so this is kamu punya K, which is number of level, and then you have your observation. Okay, only a single factor, which is the factor that we focus here, is hardwood concentration. Okay. Okay, satu lagi kalau yang tadi lah, yang dia punya mu tu ini kamu punya mu ni, grand mean dia. Okay, mu kamu, which is 15.96. Okay, nanti kita go back dia punya ni. Okay. So this is a general, okay, general form of one-way ANOVA. Yang tadi tu saya dah susun ikut dia punya ni, kita dah ada observation. Okay, let's say this one we have a single factor. Okay, so now you have 1, 2, I up to K. So this one is called either level or treatment. Okay, okay, number of level ataupun number of treatment, which is your K. Okay, this one your observation. Okay, observation for first treatment. Y11, Y12, Y1 and 1. Okay. Y1 dot. Y1 dot is your total for the first treatment. Total for the first treatment. Ataupun first level. Ini. Y21, Y22, Y2 dot. Total for the second treatment, yi dot. Total for the I treatment. Okay, and then sampailah yk dot. Total your ni, total kita punya value ni for the K treatment. Okay, this one total up semua you get y dot dot. So this one is called as your grand total. Okay, simbol yang kita pakai y dot dot, which is your grand total. Okay, so this one y1 dot, total for first treatment, total for second treatment, total for K treatment, and then y dot dot is your grand total. Okay, sebab kita nak tengok formula ni. Okay, that one. Kalau ada soalan beritahu kalau let's say tak faham pun. Okay, so this one, okay. Bila kita sebut analysis of variance, okay, analysis of variance, that's mean your variability, your variation. Okay, so now your total variability tu kita splitkan into two component. Okay, we have total sum of square. Okay, sum of square we denote as SST, total sum of square. And then you have variability, variation, variability between groups. Okay, we call this one SSTRT, which is sum of square treatment. Okay, sum of squares treatment. Okay, SSTRT lah, kita denote sebagai SSTRT. So variability within group, which is sum of square your error. Okay, so this is your sum of square of your error. SSE. So that's mean your total variation, total variability SST split into two component, which is variability between group, and then the other one is variability within group. Okay, variability between group and then variability within group. Okay, apa maksud dia? Variability between group, variability within group. Okay, ni. Okay, so bila kita cakap variability between group, maksudnya between ni, between first and second, second and third, I and K, between group. Okay, variability within group, dalam satu group ni, warasi dia. Okay, within group yang sama, within the same treatment. Itu kita panggil sebagai variability within group. Kalau variability between group, between first treatment, second treatment, and third treatment, and so on. Okay, Itu maksud dia. Variability between group and also variability within group. Okay. So kalau total sum of square, as I say, the formula is this one. Double summation. Okay, sebab apa double summation? Because kita ada treatment atau kita ada level, I equals 1 up to K. And then kita ada dia punya observation dia. So that means this one, sum of square is just Yij minus your grand mean. Okay. Grand mean, Y dot dot is just Y dot dot divided by total number of your observation. Okay. So equals to variability between group sum square treatment is just N times summation Yi dot minus Y dot dot. Okay, Y dot dot yang ni. So kalau Yi dot is just your Yi dot. Okay, divided by your N lah. Ni. Okay, sorry. Okay, kamu punya total ni. Kamu punya total tu. Yi dot divided by Ni. Okay, total for first treatment kamu tu. Total for first treatment divided by number observation dia berapa? Itu kamu dapat dia punya mean for the first treatment, mean for the second treatment and so on. Okay, Y dot minus dengan grand mean. Okay, so itu variability between group, sum square treatment. So now sum square error. Okay, sum square error which is variability within group. So double summation Yij minus your Yi dot. Okay, kamu punya mean for first treatment and so on. Setiap value tu. Okay, so that one is your variability within group. Okay, so kita akan expandkan dia punya formula. Kita akan simplifykan lagi. Ini general formula. This is your general formula. Okay, now. So bila kita dah split, bila kita dah simplify, okay, general formula tadi ni sum of square, kamu tengok kat sini. Okay, this one, sum of square. Okay, saya tulis balik je. So Yij minus Y bar dot dot square kan. So kalau kita expandkan dia punya quadratic form, simplifykan, you will get this one. So yang ini yang kita akan compute. Kita akan guna formula ni. Okay, kita akan guna this formula. Ini general formula tu biasa tak pakai lah ya. Biasanya kita pakai simplify form, which is we have double summation Yij square minus your grand total Y dot dot square divided by capital N. N besar ni adalah total number of your observation. Macam tadi tu. Kita ada 4 treatment. Your K is equal to 4. And then for each K, you have 6 observation. So all together is 24 observation. Okay, that is your sum square total. Okay, double summation Yij square minus your grand total square kan divided by capital N. Okay. So next, kita tengok pula sum square treatment. Okay, kalau yang tadi ini. Sum square treatment this one ya. Okay, bila kita dah expand this formula, sum square treatment, you will have this one, which is Yi dot square, okay, Yi dot square over Ni. Maksudnya total for first treatment tadi tu, divided by total of your number of your observation in first treatment. So yang ni Yi dot square, Y dot tu square kan, divided by Ni. Okay, minus dengan grand total dia. Okay, square kan, divided by capital N. So that is your sum square treatment. Okay, kita dah expand, kita akan simplify kan. So formula ini. Okay, formula diberi So formula ada dalam list of table kamu tu, statistical table. Kalau kamu tengok bahagian analysis of variance, cuba buka kamu punya table. Okay. Okay, you can refer on page 4. So that is the formula. Okay, you will have sum square total, sum square treatment, and then the last one is your sum square error. Sum square error is just sum square total minus sum square treatment. Okay, sebab kita dah ada ni. So ini sum square total. Ini kamu punya SST. SSTRT. Nak dapatkan SSE ni, total minus ni, dapatlah this one. Okay, so tak perlu balik, tak perlu guna formula. So just SSE is just sum square total minus sum square treatment. Okay, so itu dari segi formula. Okay, kita tak masuk contoh apa lagi, just general one. Okay, we have the formula for sum square total. Okay, sum square treatment, and then last you have sum square error. Okay, boleh follow ke setakat ni? Okay. So yang ni yang tadi kita dah test dia punya equality of the treatment mean and test for treatment effect. Okay, kalau nak mean, letaklah mu1, mu I sama dengan mu j, mu I and equal to j. So kalau treatment effect dalam bentuk alpha, setkan sama equal to 0. Alpha I is unequal to 0 for at least one of I lah. Okay. So, sekejap ya. Okay. Ini saya ikut sini dulu ya. Nanti kita tengok balik kat sini apa maksud dia. Ini pun ada dalam nota. Okay, so bila kita dah dapat tiga-tiga value tadi, you already have your sum square total, sum square treatment, and also sum square error. So you need to present in ANOVA table. So you present it in ANOVA table. So you have this one, the first column source of variation. Kau kena build up sendiri table ni. Source of variation which is punca variasi dia. Source of variation, sum of square, degree of freedom, mean square, and also F calculated. Okay. So source of variation, so this one, kita boleh tulis factor atau between label lah, ataupun kamu boleh tulis this one is your treatment. Okay. Source of variation, your treatment, your error. Okay. So sum of square, kamu punya total up tadi, value kamu sum square treatment berapa, masukkan ke sini. Sum square error, and then the last one you have sum square total. Okay. So di sini kita ada degree of freedom. So kalau kat sini kita tengok, analysis of variance is testing for variability. So bila testing for variability, so it should follow chi-square distribution. So chi-square distribution must have degree of freedom. Kalau one sample, you have n minus 1. So it's the same thing. So kalau sum square treatment, your number of treatment is k. Okay, so k minus 1. Sum square error, your total number of your observations semua tu, and minus k. Sum square total, you will have n minus 1. Okay, k minus 1, n minus k, and then the last one, n minus 1. Katakan sini lah 2, ini 9, so total up dia mesti 11. Macam tu lah. Okay. So kalau degree of freedom for treatment, k minus 1. Degree of freedom for error is n minus k. So next column, mean square. Okay, ini sum square. So mean square treatment maksudnya sum square treatment divide by k minus 1. So ini SSTRT. Okay, SSTRT divide by k minus 1. So kalau nak compute mean square error, sum square error divide by degree of freedom dia, n minus k. Itu cara kita dapat mean square. Okay, mean square. So now you have two value of your variance. So two value ratio dia akan membentuk F calculated lah ataupun F test lah, lebih kurang F yang kita compute. Okay, F calculated which is mean square treatment divide by mean square error. So this is your F calculated. Okay, procedure for testing hypothesis. We only reject H0 if your F calculated here, ini yang ni, greater than F alpha. Okay, degree of freedom, V1, V2. So V1 is K minus 1, V2 is N minus K. For example, this one, katakan F alpha 0.05, 2, nice. So dapatkan daripada table. Okay, reject dia. Only one way je how you can reject the null hypothesis in ANOVA table. So reject H0 when you have your F calculated greater than F alpha, K minus 1, N minus K. Okay, dah dapat daripada table, so check. So kalau your F calculated is greater than, so reject H0 and make your conclusion. So kalau let's say we reject and conclude that sum of the variability of the data is due to the difference in the factor level. Maksudnya kita reject yang mean dia sama tadi tu. So there is a variability lah of the data set. There is a significant difference between the variation. So itu kalau kita testing dia punya hypothesis. Once you already have your sum square total, sum square treatment, sum square error, you present in ANOVA table. Nak present macam mana dalam ANOVA table? So mesti know lah how to construct the table, which is source of variation, sum of square, degree of freedom, mean square, your F. Okay. Your treatment, your error, your total. So dah kira, masukkan balik sum square treatment, sum square error, sum square total. Letakkan balik dia punya degree of freedom. So kalau di create feeder for treatment K minus 1, this one is N minus K, and the last one is N minus 1. So compute your mean square treatment, mean square error. So ratio of 2 this one, follow your F you calculated. So reject H naught, macam one-sided lah, kita reject H naught bila F calculated greater than F alpha. So K minus 1 and minus K. So in this case, for ANOVA table, dia tak ada two-sided ya, dia tak ada alpha divided by 2. So reject H naught when you have your F calculated greater than F alpha.